Hello everyone and welcome to the first lecture of Iupac Nomenclature of Organic Compounds. Under this topic, we are going to learn how to name a particular organic or the carbon containing compound. Now this how to name a particular compound is given by Iupac. So Iupac standardizes how we can name a particular given compound, very much like our names. Okay, it has the first name, the middle name, and the last name. Likewise, Iupac says that for a given organic compound, it also must have three parts. The middle or the most important part, as per Iupac format, the most important part is the middle part or the root. Whatever comes before root is called prefix, and the part of the name that follows the root is called suffix. Further, the prefix and the suffix are divided into two parts. Prefix is further divided into a secondary. 2 degree means secondary prefix, and a primary or 1 degree prefix. Then comes root or root word followed by the suffix. Again, suffix is divided into two parts. The primary suffix and the secondary suffix. Now we will see one by one what each of this part means. Let us start with the most important part, that is root word. This root word tells us about the number of carbons present in parent carbon chain. For short, parent carbon chain we will call PCC. Sir, what is parent carbon chain? Let us learn this. Okay. The simplest carbon compound which is known to us is methane. All right. So we have methane, the simplest carbon compound. We know that carbon has 4 electrons in its outermost shell, and it will form single bond with each hydrogen using one of these electrons. Each of these electrons. All right. For short, we will write this as CH4. So here we are given a carbon compound having only one carbon. When only one carbon is present in our carbon chain or the parent carbon chain, the root word, this root word is going to be called as meth or meth. METH, meth. Now, instead of bonding with hydrogen, this carbon could have bonded with one more carbon. All I did is I removed one hydrogen and replaced it with carbon. Now the carbon has 4 valency. You see, this one valency is satisfied, 3 valencies will remain. Total 4 valencies. Let us keep hydrogen at each place. So now we have, sir, CH3 bonded to CH3. CH3 bonded to CH3. Now we will say that our parent carbon chain or the carbon chain has 2 carbons. Root word will become eth or eth. Likewise, as the number of carbon goes on increasing, so when the number of carbons is 1, then the root word becomes meth. When the number of carbons are 2, then it becomes eth. If it is 3, then it becomes prop. Likewise, 4, then but. 5, then pent. Likewise, if the number of carbons are 6, the root word would become hex. 7, then it would become hept. 8, then it would become oct. 9, then it would become non. Further, if it is 10, then we would call it dec. 11, then undec. 12, then dodec, and so on. All right. So let us come back to our format. So format is divided into 3 parts: prefix, root, suffix. Prefix further divided into secondary prefix, primary prefix. Likewise, suffix divided into 2 parts, primary and secondary. We are right now focusing on the root part. Root part tells us how many carbons are present in a parent carbon chain. For example, if the number of carbons is equal to 1, the root would become meth. If it is 2, it would become eth. If it is 3, it would become prop, and so on. The secondary suffix, the next part I am going to pick up, is the secondary prefix. The secondary prefix tells us about the substituents. Substituents. There might be more than one substituents. So in case we have more than one substituents, then substituents are written in alphabetical order. Along with locants. All right. Sir, what are substituents? Let us try to understand what are the substituents. Okay. As I told you, we will have a parent carbon chain like this, and it may have any number of carbons. So this we shall say is our parent carbon chain. Now whatever is left outside of parent carbon chain, let us say there is one carbon here, let us say there is one carbon here, it is not possible to include them in our parent carbon chain. So these guys, they become our substituents. How to name these substituents? It's quite simple. For example, I told you, sir, CH4 is methane. CH4 is methane. CH3 is called ethane. Likewise, propane, butane, and so on. From methane, if I remove one hydrogen, see, methane was looking somewhat like this. If I remove this hydrogen from here, then I will be left with CH3 and one free valency. This part CH3 with one valency. See, CH4 is methane, CH3 with one valency is called methyl. Again, meth is the root word. What is that in? What? Okay, over here we will discuss that. Likewise, in case 2, I'll simply free one valency over here. I had CH3, like this. If I free one valency over here, what I'm left with is CH3, CH2 with a free valency. Very much like methane became methyl, ethane would become ethyl. Likewise, propane, from propane, if you remove one hydrogen, if you free one valency, it would become propyl. From butane, if I remove one hydrogen, it would become butyl, pentyl, hexyl, and so on. In general, I can say that, in general, we can say that From alkane, if I remove one hydrogen, methane gives methyl, propane gives propyl, alkane gives alkyl. For example, let us say that I have two substituents, methyl and ethyl. Then how would they be named, or how would they be written in secondary prefix? First ethyl would be named, then methyl. Why? Alphabetical order. Alphabetical order means if you look up for these two words in dictionary, then ethyl word would occur before methyl. Okay, ethyl would occur before methyl. Why, sir? In ABCD, E comes before M. That's called alphabetical order. Okay, any word that would occur first in a dictionary is given preference. It is written first. Likewise, butyl and propyl. Of course, B comes before P. So butyl would be written first in the secondary prefix, then propyl. Sir, how about butyl and ethyl? What if we were given butyl and ethyl? A, B, C, D, E. So B comes first, E comes later. Butyl would be named first, ethyl would be named later. So this is how we go about with substituents. There are few more substituents. The most commonly known substituent is from alkane, we remove one hydrogen, we get alkyl. By the way, these substituents which have one valency free, so with that valency, what it is going to do is that substituent is going to hold the parent carbon chain. Again, methane, we removed hydrogen, so it has one free valency, like this one free hand. So with that one free hand, it is going to hold to PCC, parent carbon chain. Such substituents which have one hand or one valency free are called monovalent radicals. What are they called? Monovalent radicals or monovalent substituents. We could also have bivalent substituents or bivalent radicals. If we had to not remove one but remove two hydrogens, then instead of monovalent, I would get bivalent radical. Likewise, if I had to remove three hydrogen, I would get trivalent substituent. For example, let us say that from methane, if I remove one hydrogen, I get methyl. But if I remove two hydrogens, then I get, all right, two valencies free, sir. Two valencies free. So this is not called methyl. It has to have some other name. This is called methylidine. Methylidine. And this is going to be our bivalent radical or bivalent substituent. Let us see some more. We'll have CH3. So from CH3, I remove two valencies. So I had three hydrogens, I removed two, so I'm left with one. Very much like methane becomes methylidine, ethyl would become ethylidine. Please pay attention that in case of methane, I removed these two hydrogens. That is, I removed hydrogens from the same carbon. Likewise, in case of ethane, I removed two hydrogens from the same carbon. The substituent came to be known as ethylidine or ethylidine. However, if I had to remove one hydrogen from here and one hydrogen from the next carbon, this positioning is called vicinal. These carbons are vicinal, means neighbors. Whereas, okay, I'll come to that. So when the hydrogen is removed from two adjacent carbons, it doesn't become ethylidine, it becomes, in this case, ethylene or ethylene. These are called bivalent radicals. Some other substituents which we must remember is fluorine. The name of this guy would become fluoro. likewise. Chloro, likewise. Bromo, iodo, and so on. All right. So that was our secondary prefix. Root word indicates how many carbons are there in PCC. Secondary prefix tells us about, gives us information about substituents. The primary prefix tells us whether the parent carbon chain is cyclic or non-cyclic. Okay, cyclic would be like this: 1, 2, 3, 4, and the fourth carbon is connected with the first one, so it forms a cycle. That's called cyclic. Whereas if they were not connected, then it would look 1, 2, 3, 4. This is non-cyclic. If a given PCC or the given compound doesn't contain cycle, then primary prefix is not important. Primary prefix is not a essential part of IUPAC nomenclature. Primary prefix may be there. In some cases, it may not be there. All right. So primary prefix tells us whether given compound is cyclic or not. If it is cyclic, then prefix will come as cyclo, like this. How many carbons are there? Check. 1, 2, 3, 4, 5, 6. So the root would become hex, and the primary prefix would become cyclo. So it would become cyclohex. However, if it is not cyclic, then it is not mandatory for us to write. There are some hydrocarbons which have some weird structure, so something like this. So now it doesn't have a one cycle, rather it has two cycles, one on the right side, one on the left side. In those cases, I will not write primary prefix as cyclo, but I would write it as bicyclo. Yeah, guys. Or like this. There is one carbon outside, like this. It's like a bridge. We have a normal hexagon, cyclohexane, and then there is a bridge like this over there. All right. So they are called bicyclo. There are one more type of cyclic compounds. They are like this. Like this. Where two rings are fused using only one carbon. So one carbon is common. They are called spiro. Spiro. So the primary prefix could be only one of these three. It could be cyclo, it could be bicyclo, or spiro. Otherwise, there will be no primary prefix. Fourth option is no primary prefix. It's not a compulsory part of IUPAC naming. Every compound will not have primary prefix. Every compound may not have secondary prefix. Root, that's why I said, is the most important part. Achha, in our JEE syllabus, cyclo is the most important. Bicyclo, spiro may be asked, but not very important. As in, rarely asked. All right. Let us move to the primary suffix. The primary suffix tells us whether our PCC or our hydrocarbon is saturated or unsaturated. Saturated or unsaturated, like this. Sir, what do you mean by saturated and unsaturated? When in a given hydrocarbon you see all single bonds like this, 1, 2, 3, 4. So when all the carbons are held by a single bond, then we say that such a hydrocarbon is saturated. Saturated. Saturated means it already has maximum number of hydrogens that it can hold. Whereas if I have one double bond, say, then we say that such a hydrocarbon is unsaturated. Presence of even one double bond will make it unsaturated, and same thing is true about a triple bond as well. If all carbons are linked together by a single bond, saturated. If there is at least one double or a triple bond, then unsaturated. In case our PCC is saturated, then the primary suffix would become "ane", like ethane. This guy is eth. Sir, eth is root word, and the primary suffix, since they are linked together by a single bond, would become "ane". The name of CH3 compound in that case would become ethane, methane. Likewise, 1, 2, 3, 4, bute. All are single bonds. Therefore, the name of this particular compound would become butane. Bute tells us that this particular compound has 4 carbons. Ane tells us that all carbons are bonded together by a single bond. Sir, how about the prefix part? There is no prefix. Why? Because it is not cyclic. So cyclo is not required. The primary prefix is not required. Secondary prefix is substituent. Do you see any branch coming out from here? Do you see any substituent connected with this PCC? No. So my point is that prefix is completely optional. Optional as in not optional for us, but for a given hydrocarbon. Prefix may be there, may not be there, but root 100% will be there. जैसे अगर मैं बोल दूं 1, 2, 3, 4, 5 and the fifth and the first one is connected. In this case, you see, sir, there are 5 carbons. If there are 5 carbons, in that case, the root would become pent. The root word would become pent. All are single bonded, so it would become ane. The primary suffix would become ane. Now think about primary prefix. Is it cyclic? Yes. So the name would become cyclopentane. Likewise, the name of this guy would become cyclohexane. So if they all are single bonded, then ane. If there is at least one double bond, then ene. If there is at least one triple bond, then ine. If there is double bond also and there is triple bond also, then what? Then it would be ene, ine. Okay, ene, ine, both will be there. If there are 2 double bonds, if there are 2 carbon-carbon double bonds, then we will call it a-diene. Di means 2. Ene means, sir, double bond. E means a double bond. Ene means a single bond. Ine means a triple bond. A-diene means there are 2 double bonds. If there are 2 triple bonds, then the primary suffix would become a-diene. A-diene. That A is important. All right. And then the most important part after root word, of course, would be the secondary suffix, which tells us about something called as functional group. Which tells us about something called as functional group. Sir, what is functional group? Let us check. The secondary suffix. Let us say that I was having methane, so I had 4 hydrogens, and the 4th hydrogen, okay, the hydrogen which was present over here, I replaced it with something other than hydrogen or carbon. Like for example, I replaced it with oxygen and hydrogen. This particular OH, this particular group of atoms or a single atom in some cases, will make drastic changes in the behavior of this particular compound. So CH4 belong to a different category, and CH3 along with OH now belongs to a different category. Sir, what is that category? That itself is called functional group, because it will change the very characteristic, the very behavior of that particular compound. So OH is called alcohol. Alcohol. Likewise, I may have CH3, CH3. But now this hydrogen I replaced with OH. Which functional group is this? This is a alcohol functional group. There are various functional groups, all right? So I'll give you the list of these functional groups along with their priorities. Sir, why priority? We'll discuss it. One functional group looks like this, COOH. It is called carboxylic acid. This gets the highest priority. Sir, priority means what? I'll explain you. SO3H. S, 3 O's and H. This is called sulfonic acids. That is second in priority. Then comes a category called as esters. So I am simply replacing hydrogen with R. Sir, what is R? Some carbon chain. 1 carbon, 2 carbon, 3 carbon. It could be any carbon chain. They are called esters. Esters. Then we have, okay, in this case I will replace OH with Cl, Br, any halogen. X is what? X is a halogen. It could be chlorine, bromine, iodine, like that. They are called acid halides. Acid halides. Next case, I will replace this OH with NH2. They would be called amides. Now from amides, if I try to remove water, see how water is what? H2 and O. If I remove this water, H2 and O, then what will I be left with? H2 gaya, O gaya. What would I be left with? Sir, you would be left with carbon and nitrogen. You would be left with carbon and nitrogen. H2 and O are gone. These are called cyanides. But cyanide is called common name. We don't generally use it in IUPAC standards. We rather call them nitriles. Next in priority are aldehydes. Then ketones. So the difference between aldehyde and ketone is that aldehyde has a hydrogen on one side and a carbon chain on the other side. Say this, C double bond O with carbon on one side, hydrogen on the other side. Whereas ketone has carbons on both sides. This side also carbon, this side also carbon. Yahan pe bhi carbon, yahan pe bhi carbon. But aldehydes are not like that. Only on one side they will have carbon, other side they will have hydrogen. So we have aldehydes, ketones, after that we will have OH. OH means alcohol. Finally, we will have amines. There are a few more functional groups, but these are the most important ones which are required for our IUPAC nomenclature. So let us quickly revise what we have done today. We learnt that any carbon compound, in order to name it, we need to follow one format of IUPAC. According to that format, name should have 3 parts. The middle part would be called root. The part before it would be called prefix. The part after that would be called suffix. The prefix is divided into two parts, primary, secondary. Root in middle, and then suffix also divided into two categories or two parts, primary and the secondary suffix. The root tells us how many carbons are present in parent carbon chain. The prefix, secondary prefix, the very first part, speaks about the substituents. Sir, what are substituents? Sir, if there is this carbon chain, ऐसा carbon chain है sir, then it is not possible for me to include this carbon in the chain. Okay, so whatever is this hanging outside, this guy, or let us say here there is something like bromine and so on, then they would be called as substituents. Secondary suffix will have substituents. Primary suffix will tell us whether the particular compound is cyclic or not cyclic. If it is not cyclic, you need not write anything in primary prefix. If it is, then we need to write cyclo. Root word tells us about the number of carbons in the parent carbon chain. For example, over here, parent carbon chain has 5 carbons. So the root would become pent. Primary suffix then would become all are single bonds. So ane, propane. And the last part, the secondary suffix, the most, after root, the most important part is the secondary suffix, which is the functional group. Now, in this case, the name would be pentane. Where is the functional group? There may not be functional group. I told you. For us to have functional group, we need to replace one of the hydrogen with something called as heteroatom, like OH, like SH, like NH2, something other than carbon and hydrogen, or some unique group we will place. So secondary suffix likewise is not very important. Not very important in a sense, optional. It may be or it may not be there. All right. So for a given hydrocarbon, root will 100% be there. Primary suffix will 100% be there. But all other parts may or may not be there. So today we only focused on one part of IUPAC nomenclature, and that's what? That is the format of IUPAC nomenclature. Prefix, root, suffix. Prefix divided into secondary, primary, then root, then primary suffix, secondary suffix. So that's it for today. In our next class, we will learn what is PCC. I mean, I have just explained it to you, but in next class in detail we will learn what is PCC, and if I am given a particular compound, how to select PCC. Thank you.